Um, all right, yeah, hi, I'm Willem. I'm a postdoc here at the Transit Analytics Lab. I'm going to talk a little bit about a project that involves a great number of wonderful people, and you've seen some of them today, and you will see some more. People from University of Toronto, Scarborough, University of Texas at Austin, University of Vermont, and the project was funded by Transit Center, which is a transit advocacy group in the United States. And I'm going to talk a little bit about a dashboard that we built, which you can go and have a look at your leisure at dashboard.transitcenter.org, which looks at accessibility and equity. All right, so the key sort of underlying part of this research is a concept called accessibility. If you're not familiar, transit accessibility, I'm not talking about physical accessibility, which of course is extremely important, but it shares a word with transit accessibility, which is really about measuring the freedom of choice that a transit system, or really any transportation system, gives you. There's two ways that we measured accessibility. There's sort of two different ways to measure it. One is to look at a certain origin point and count all of the number of destinations you can reach within a certain time frame. So that's what you see here with the blue boxes and the blue arrows. You can reach 5 blue boxes, which could be jobs or grocery stores, within, say, 45 minutes by transit. And then the other way is to look at what the nearest of a certain destination is, or the third nearest of a certain destination is, by transit from your origin point. So what's the third nearest grocery store or the nearest hospital, and how long does it take to travel there by transit? And so we use both of these measures in the dashboard, as you will see. Some of the research questions that I think we started with the project, and also evolved over time as COVID showed up, was to look at differences between socioeconomic groups in terms of this measure of access. We wanted to look at how access changed during COVID-19 as transit agencies started to adjust their schedules or make cuts, and how did those cuts affect all of these other things that we were measuring. We wanted to be able to show that different destination types, we need to sort of measure different destination types. Often jobs is sort of used as a stand-in for everything, but of course, if somebody's going to use transit sort of for their daily life, they need to be able to reach all sorts of different destinations. And so we wanted to look at those different destination types. We also wanted to look at the competitiveness between transit and car accessibility in a city. A really interesting thing we looked at was looking at fare budgets. So if you have a limited fare, if you don't have a lot of money to spend, there's certain trips that may be unavailable to you because, for example, in the GTA, GO Rail is more expensive than taking the sort of parallel bus that may run longer. And so we wanted to look at what the effects of having a restriction on how much money you could spend on a given transit trip gave you. And then we did some looking at transit service reliability, which you can look at yourself. I won't get too much into it in this presentation. So to calculate accessibility, you really need to assemble a bunch of data together. The first is destinations. You need to have a source for each of the destinations that you're looking at. The census is a great place to start. We used a database of food stamp retailers. We pulled some data from OpenStreetMap, which is sort of a Wikipedia for maps. We also pulled from other US government sources, and a lot of these sources are also available in Canada as well. So once you have some destinations, you need to figure out how long it takes you to get to each of these destinations from each of the origins that you're interested in. So we had to calculate transit travel times, which we did using OpenTripPlanner, which Brendan just mentioned in his previous presentation. It's an open source trip itinerary generator, just like Google generates a transit itinerary trip. This does a similar thing. And from that, we can make measures of how long it takes you to get from point A to point B by transit. And then for cars, we used EsriStreetMap and HERE data to get travel time matrices for cars as well. In order to get an understanding of fares, we had to go and look at the agency websites and build effectively a database of fare rules. We had to go through and figure out, what the transfer rules were in a given agency and how much time you were allowed to spend on a single fare before it expired or flipped over again. And so we built a fare rules database and a calculator. And then we combined that with the travel time itineraries that we got from OpenTripPlanner to develop a fare matrix. So we knew roughly how much it costs to get from one zone to another zone. And we actually did that in two different ways. One was to look at the whole transit network, and the other one was to remove the expensive routes. So again, if you're thinking in a Toronto context, that would be to remove the GO Transit routes and recalculate it to allow for some potential trips that take cheaper transit, but obviously are maybe more roundabout or take longer as well, but can still be counted in accessibility. And so all of that you put together into measure accessibility. And then if you start to measure it and weight it with different population groups, socio-demographic groups, you can start to get a picture of equity in transit equity in these cities. So one of the big challenges was the different types of possibilities that were basically the different types of maps and the different types of data sets that we were producing. We used 9 different destinations. Each of those had 2 to 3 measurement options. Some of those were fare and non-fare restricted, so they were capped and not capped. We did 2 to 3 times a day, AM peak, evening service, and Saturday midday service. We looked for some of the measures at a ratio between auto and transit. So we looked at that auto transit competitiveness. And then the regions we looked at there was 7 regions, and the regions we looked at span from 3,000 up to 14,000 block groups, which are little zones that are somewhat equivalent to dissemination areas here in Canada. And then over the course of February 2020 to February 2021, we looked at the transit schedule each month and how it had changed, and we reran the analysis 12 times for 12 different months, which resulted in about 146 million different scores, different data points effectively. And so the challenge becomes, how do we now provide a way for people to browse this information and look at this information, visualize this information? And so we put together, the idea was to put together a web dashboard and a little bit of a behind the scenes of how that works. We built a web server, which is able to query a database, which holds all of this massive amounts of data. And the web database basically takes requests for data from a client-side application, which was all written using open source packages. So Leaflet is a mapping application written in JavaScript. D3 is a chart and other visual application written in JavaScript. And so the client side would ask for specific data types and different data sets, and it would come back to the web server. The web server would ask the database and then pass it back to the user. And all of this is running on a cloud, an AWS cloud instance. Okay, just a couple of pictures of what the maps look like. What are some of the things you can do with the tool? Here you can see the economic region of New York. We are showing access to grocery stores. So this is the travel time it takes to get to the 3rd closest grocery store, colored by various bins you can see in the top right. Immediately, of course, you can see some intuitive results, which is to say that, you know, downtown New York, much denser, lots of grocery stores, lots of people, lots of transit. Scores are very good. But then as you follow some of the major transit lines there in black out, you start to see how there's a bit of a spatial correlation between where the transit lines are, which also may be where it is dense, and where the scores are better. And the timeline on the bottom lets you pick which month you'd like to look at, what kind of picture you'd like to look at for what month. We're looking at August of 2020 in this case. We also added the option to overlay population demographics using what we call a dot map. And so in this picture there, you can see some small dots on the map. One dot in this case represents 100 people living below the poverty line. And the choropleth map that you're looking at looks at the accessibility to low wage jobs in the area relative to the rest of the city. And so you can start to, as you look through this, if you're trying to tell a story about a city, you can start to see potentially areas where access to low wage jobs does not correlate spatially with where low wage folks live. And so again, you can see how that might change over time as well. And of course, if you take all of this information and you sort of sum it up and average it over the whole city, you can start to generate regional summary stories. And so every of all the regions have a summary story page, which produces a number of charts based on the data that's there. In the top right, you can see the ratio, the comparison between travel time by car and by transit in Washington, D.C. to a bunch of different destinations. Gives you a stark sort of image of just how competitive or not competitive transit might be in the city in terms of travel time. Top left, you can see a measure which we're calling transit service intensity. This is basically just taking the number of unique trips that pass near a zone over the course of the day and then averaging it to get an average trips per hour over the day. And with this, you can see how transit service has dropped heavily, quickly during the start of the pandemic, and then has sort of slowly recovered. And then below it, you can see a similar measure, which is looking how that change then ended up affecting the accessibility to jobs. So the number of jobs you can reach in 45 minutes. All of this is in Washington, D.C. And it does show you a breakdown by different demographic groups. So for example, in Washington, you can see that there's a large gap between the jobs that are accessible by white folks versus basically everybody else, and how that gap might change over time. And finally, we did a summary to show the number of jobs accessible by low-cost transit trips. So for what percentage of all jobs could you reach if you had a restriction on how much fare you could pay? So twice of a regular transit trip for a one-way trip. So in Washington, D.C., on average, you can only reach 77% of the jobs you could reach if you have an unlimited fare budget. You can also download the data and make your own maps. Just got a couple to show you. This is showing that same measure, that percentage of fare jobs reachable in San Francisco. And you can see, so brighter colors means a larger discrepancy, a sort of smaller percentage of the total. And so you can see that the bright areas are lined up with the more premium routes, such as the Caltrain and some of the other commuter rail services. You can also take two different dates. So this is looking at that transit service intensity as well in San Francisco and how it changed between March 2020 and February 2021. And so darker orange means a larger decrease in transit trips in that area, and purple is an increase. And so you can see, across the board, there's generally a drop. A few places got increased service or refocused service, and there seems to be some areas where service was sort of still removed entirely and hasn't resumed yet. So the key takeaways, accessibility is a great way to connect transit planning and land use together to get a good measure of the freedom that the transit system provides to people. All of this, except for the auto travel times, all of this was done with open data and software. All of the code is open. All of the data was open. So you can use this. This is something that an agency can reproduce in their own area. It was not, it doesn't require a huge amount of data to pull together, although you produce a lot of data. And combining accessibility and population data lets you sort of be able to compare and enables conversations about transit equity, which is extremely important as well. Happy to answer any questions. And again, feel free to browse it at your own pace at dashboard.transitcenter.org. And a huge thanks to all of the folks and companies that worked on this together.
Hey, thanks a lot, Willem. We've had some questions about, I think, the HERE data, and I think Steve had responded to some questions. Maybe if you can just very quickly, for the benefit of everyone, talk about the HERE data, how it was used in this project.
That might be better answered by Steve, actually.
Yeah, well, I see that he's responding to some comments. I can't really follow.
Yeah, he used it. I mean, it's a bit of a blank, a little bit of a black box to access the HERE travel time data. Although I know that different regions may have travel time data from other studies or other models that they use. So that might be something that an agency already has. And if they don't, then that's something to explore.
But that was mainly auto travel time data.
Yes.
The transit travel time data we got from other sources.
Yeah. Beat Steve. Okay. Yeah, I'll look through and see
And-
if there's any other questions.
Sure. Okay. Well, thanks a lot, Willem. And again, anybody who has questions to Willem or other speakers, please add them to the chat box.